Hello and welcome to this tutorial. This is Casey and we continue with our linear inequality problems. And previously I spoke about the consequences of multiplying or dividing a linear inequality by a negative number and how you have to change the linear equality symbol. I want to use one of the analogies that has really helped me to flip around those inequalities. You just have to count the number of edges. So we have two edges which is greater than. On the side that we have one edge is less than. So if I say 3 is greater than 2, we can equally say 2 is less than 3. Now what definitely we are doing here is we are switching positions of the inequalities, and at the same time we have to change the symbol of the linear inequality. But if you apply this analogy, it becomes so easy. Whenever we have two edges, we read it with greater than. Whenever there is one edge, we did it at less than. That's why we are reading 2 less than 3. But definitely it still holds in terms of its definition. 3 is greater than 2 and 2 is less than 3. Now I want us to go through quick examples so that we grasp the concept and how and its application. X plus 3 is greater than 5. All we have to do is just subtract both sides by 3 and we get x is greater than 5 minus 3. Therefore x is greater than 2. We have an open circle because 2 is not included and it goes all the way to, this is on the number line, all the way to positive infinity. Representing this in an interval notation, we have round bracket 2 comma positive infinity. And infinity, as I explained, is also round bracket, positive or negative. The next problem we can address here is 3x plus 4 is greater than 6x plus 10. Now we do have to collect like terms. We have 3x minus 6x is greater than 10 minus 4. This we get negative 3x is greater than 6. We divide both sides by negative 3, and this cancels out, and the consequence of this, we have x is less than negative 2. Remember, we are flipping the sign because we've divided the equation by a negative number. If we go ahead and represent this into our number line, x is less than 2, an open circle that starts from negative 2 all the way to negative infinity. So in our interval notation, I have negative infinity, comma, negative 2. Always you have to read interval notations from left to right. That's why we start with negative infinity to negative 2. Okay? Our next problem is a bit complex, but it helps us to apply a couple of things that we've learned so far. This is negative 2 is less than 4 minus 2x over 3 is less than 4. This equation has three parts. The first part has 2, then the inner part, and then the outer part. For me to remove the fraction, I have to multiply by 3. I have to multiply by 3 and 3 on this other side. I will get negative 6. Of course, this cancels out. Then I have less than. Remember, I haven't multiplied by a negative number. It's just a positive number. 4 minus 2x is less than 12, right? So the next thing I have to do is I have to remove 4 in the middle of the equation. I have to subtract by 4. So I can simply do it from here. Minus 4, minus 4, minus 4. You have to do the same on all three parts. So we get negative 10 is less than, 4 cancels out, negative 2x is less than 8. Cool. Let's leave the negative first. Let's divide everything by 2. Divide by 2, divide by 2, divide by 2. We get negative 5 is less than negative x is less than 4. So eliminating the negative sign, I have to divide by negative 1, and negative 1. And the consequences of this is we have 5 now, which is greater than x and greater than negative 4. Remember, we are changing the signs because we are dividing the equation by a negative number. If I was to put this in a number line, x is greater than -4, which we have 4 here, and it definitely goes this direction. We have x is less than, you count, let's count the edges. So x is less than 5. It's an open circle, and x is less than 5. So basically, this whole equation represents this area of the number line. And again, since we have to read it from left to right, what we have to do is we have to read it in this sequence where we say -4, now we are reading it this direction, is less than, remember the angle is less than x, and also is less than 5. So you can see the relevance of using the count of edges to guide you on how your equal signs looks like. You have to represent this into 2 solutions, and the first solution, x is greater than -4. And the second solution is x is less than 5. Okay, if we were supposed to write it into interval notation, I have to put -4, 5. And this is our solution for this problem. And I hope you have understood the concepts and steps that we've taken to solve this as it's required. Thank you, and in my next tutorial, we will work on rational inequalities.